Hello everybody and welcome to a video on section 7.5. The reason you are watching this is because class was canceled due to the snow and roads, so we're watching this in lieu of coming to class. So just to motivate what we are going to do, in section 7.4 we solved these kinds of equations. Sine of theta is a half, 6 cos theta plus 3 is 0, 2 cosine squared theta minus 7 cos theta plus 3 is 0. Okay, we solved these back before break. So in section 0.5, we'll sort of kick the difficulty up a notch and solve equations that look like these. 1 plus sine theta equals 2 cosine squared theta, etc. So if you think about what's happening in these three equations down below, first of all, they do not look like sine of theta equals a number, cosine of theta equals a number. So they are superficially more difficult because of considerations like that. But also notice this first equation here, it's sort of quadratic because it has a cosine squared, just like this equation here is a cosine squared. But notice down here the other term is sine theta, not cos theta. So we'll have to come up with some other way of dealing with an equation like this, because when you have a mismatch of terms, you have a cos theta here, a sine theta here, you can't just try to factor like we did here in section 7.4. And these other two equations, having not a theta, but say a 3 theta or a 2 theta, introduces new wrinkles that we'll have to deal with. So anyway, the goal of this section is to deal with slightly more complicated equations like these. So I will just show you how to solve all three of these. So let's start with this one. So how do you solve something like this, where there's a mismatch of terms, a sine theta there, and a cos theta there? Well, just as an aside, recall this, that sine squared plus cosine squared is 1. Therefore, the square of cosine, which I have in this equation, right? The square of cosine can be written in terms of sine if you want. Cosine squared is 1 minus sine squared. So what does that mean back in terms of this equation? It means I can just replace a cosine squared with a 1 minus sine squared, which on some level makes the equation look more complicated. But notice the second equation here, they're only sines. There's a sine theta on the left, a sine theta, which happens to be squared, on the right. And so now all of the terms are of the same form. You don't have both sines and cosines floating around. You only have sines floating around. So once we simplify this equation, once we expand things out and group like terms, we're going to be back in section 7.4. We're going to be back looking at an equation like this, where you have a cosine theta, cosine squared theta, except in this case we'll have sines. Okay, so I've replaced cosine squared with 1 minus sine squared, so let me just put that 2 in there. So on the right I have 2 minus 2 sine squared theta. And now let me just put all terms on one side. So I'm going to add the 2 sine squared over. I will subtract the 2 over, meaning I have a minus 1 right there. And now I have a quadratic equation in terms of sine. So in this case, things factor nicely, like they did in section 7.4. So I have 2 sine theta minus 1 as one term and sine theta plus 1 as the other term. And so I can just set each of those individual guys equal to 0, and I learn that sine of theta has to be either a half or sine of theta has to be negative 1. Either of these equations, right, these are the most basic trig equations, the kinds of things we started with in section 7.4, so I can just solve them individually. Where is sine 1/2 at these kind of angles, 30 degrees or 150 degrees, plus a full rotation, Where is sine of theta equal to negative 1? Well, that's at the very bottom of the unit circle at 270 degrees. So sine is only negative 1 at one place on the unit circle, but sine is a half a couple of places, 30 and 150. So all of that to say, we started with an equation that was fairly complicated, and we reduced it down to just solving these two individual equations, which are not complicated. So here's a problem for you to try. Solve this. Cos theta equals 2 sine squared theta minus 1. The solutions are here, so you can check your work. So go ahead and pause the video and try solving this. Okay, assuming you are now back after having paused the video, let me just say the way that you solve this is the same as before, except now I have a cos theta over here and a sine squared, whereas before I had a sine and a cos squared. Okay, but sine squared, recall, right? If you look at this equation, this aside, sine squared is 1 minus cosine squared, just like cosine squared is 1 minus sine squared. So right here, you can replace this sine squared with a 1 minus cosine squared. So this problem is just kind of a mirror image of the one we did, where instead of replacing a cosine squared with something with sine, you're going to replace the sine squared with something with cosine. And that's how you solve it. Okay, so let's move on to the second equation that I said we would solve. 2 times sine of 3 theta minus 1 equals 0. So first, let me just point out that you can add the 1 over and divide by 2. And so you're really just solving sine of 3 theta equals 1/2. So how do you deal with something like that? Well, just as an aside, if sine of whatever, sine of stuff, is 1/2, then we know what that stuff has to be, right? What targets a half? What angles will give you a half for sine? Those angles are 30, 150, or of course some full rotation of either of those. So all of that to say, if sine of stuff is 1/2, you know what that stuff has to be. It has to be 30, 150, or some full rotation. So if sine of this particular stuff, 3 theta equals 1/2, well then you know that stuff, that 3 theta must be 30 or 150 up to a full rotation. And so now if you want to isolate theta, right, your goal is to solve for theta, well you have an equation that says 3 theta equals all this stuff over here, right? So just divide by 3 to figure out what theta is. And dividing by 3 means just dividing everything in sight by 3. So 30 becomes 10, 360 becomes 120, 150 becomes 50, and so on. So the solutions of this equation are anything that looks like 10 degrees or 50 degrees plus a third rotation, not a full rotation. All right, so 3 theta was 30 or 150 up to a full rotation, but if you divide everything in sight by 3, you're not going to have full rotations anymore. You will have a third of a rotation, and that is how you solve sine or cosine, whatever, of stuff equals a number. You can just figure out the angles that target that number, and then once you have a full form like this, you can divide by this number here, this 3 in this case. So all that to say, let's have you try this. Use a calculator for this one. Use a calculator to solve this equation. 3 sine 4 theta plus 1 is 0. Round your answers to 2 decimal places. Again, these are the solutions, so you can check your work. Okay, so go ahead and pause the video to try to solve this. Okay, so assuming you have paused the video and are now back, let me just say that this equation becomes sine of 4 theta equals negative 1/3. You subtract the 1 over and divide by 3. So back up here we had plus a half because we added 1 over and divided by 2. Here we have negative 1 over 3. So sine of 4 theta equals negative 1/3. Well, negative 1/3 is not a friendly output for sine, which is why you have to use a calculator. So hopefully what you did was you calculated sine inverse of negative 1/3 to get you this angle, or something like this angle here. And then of course, sine inverse gives you the angle in the 4th quadrant, but there's another one in the 3rd quadrant whose sine value is negative 1/3. So you can figure that out. And then you divide everything in sight by 4. So I think sine inverse of negative 1/3 is like negative 19 point something degrees. So when you take negative 19 point something, cut it by 4, you get that number. And when you take the version of that angle over in the 3rd quadrant and divide it by 4, you get negative 40.13. So hopefully that's what you did. Okay, so finally, let's solve this. Sine of 2 theta minus sine theta equals 0. So here, What's bothersome is that here you're taking sine of theta, here you're taking sine of 2 theta. So you're sort of comparing apples and oranges or something, you know. So you're trying to figure out when sine of theta and sine of 2 theta, which is a sine wave, you know, but it has a different period, you know, it's moving at a different rate than sine theta. When do those things sync up? And just as an aside, you actually don't really need to think about that because we have this identity. We know that sine of 2 theta is just 2 sine theta cos theta. So perhaps you could use that, you know. So let me just put that in here. 2 sine theta cos theta minus sine theta is 0. Well, if you stare at this long enough, you realize, oh, sine of theta is in both spots here. So you could factor that out. And what's left in the first slot is 2 cos theta. And what's left in the second slot is just a 1. Okay, but now you have a factored equation, equaling a factored left-hand side equaling 0. So just like any time you have something factored equaling 0, you can just peel off the two pieces. So either sine theta is 0 or 2 cos theta minus 1 is 0. So either sine theta is 0 or cos theta is equal to a half. And once again, we're in the situation where we just need to figure out sine theta equals some number or cos theta equals some number. We can do that. Sine of theta is 0 when theta is 0 degrees up to a full rotation, or 180 degrees up to a full rotation. Cosine of theta equals a half at either 60 degrees or 300 degrees up to a full rotation, and you have solved the equation. Okay, so lastly, let's have you try this. Cosine of 2x plus 3 sine squared x equals 2. Here are the solutions. My apologies, there should be a degree symbol here, 270 degrees. So pause the video and see if you can solve this, keeping in mind, right, that the way we solved this was to use a double angle identity. So pause this and see if you can solve. Okay, so assuming you pause the video and are now back after having tried this, let's walk through this one. Recall that cosine of 2x has 3 formulations. There are 3 equivalent ways of writing that, and one of those ways is this, 1 minus 2 sine squared x. So cos 2x is 1 minus 2 sine squared x. So you can just replace that. And the nice thing about that particular replacement is that you already had just a sine squared there. So if you replace this with its formulation that involves just a sine squared, you'll have like just only apples and apples, you know? So I have a 1 minus 2 sine squared plus a 3 sine squared is equal to 2. Okay, well, minus 2 plus 3 sine squared, you're just left with a plus sine squared. And you can subtract the 1 over and get sine squared x equals 1. So sine of x has to be either positive 1 or negative 1, and that occurs precisely at 90 degrees or 270 degrees. Okay, so in this video, what is the takeaway from this, right? The takeaway is that sometimes you can use identities like a double angle formula, like sine squared plus cosine squared is 1, as we did in the first equation. Sometimes you can use those identities to get yourself an equation you can solve from an equation you really couldn't solve. Like this is hard, you know, without doing some sort of footwork, you know, some sort of manipulation. So you can do like a double angle or a Pythagorean identity to get your equation to something you can solve, or something like this, right? You can sort of think it through, but in the end, you'll have to end up dividing your solutions by like a coefficient here maybe, right? You'll have to set your stuff equal to these angles and then deal with the stuff individually, like here. So 3 theta was all this, so we had to divide by theta, or divide by 3, sorry, to get theta by itself. Okay, so hopefully that was clarifying. There were these practice problems in this video that hopefully you found approachable. There is an optional homework assignment on WebAssign, so it's not for credit. But if you want to see what kind of problems might appear on a quiz or might appear on your next exam, I strongly suggest you try out that homework assignment by tomorrow night and let me know if you have any questions on anything.